coming from the generator. And you can see here's generator input 1 and generator input 2, which not everybody's system is going to be like this. My particular system is 3-phase or 240, so it's got 2-phase power instead of just 120. And this white here, this is the neutral, and you can see this is just going to a bar. It says AC neutral. And then here's your second power. Here's your second power wire down here. And this is generator hot leg 2. So in the event that, and right here, this is ground. Now ground and neutral are not the same thing, although they both do eventually go to ground. But when people say ground, what this really is just a safety ground. And this, the white one, is the actual ground. So this was for the generator. And now we got left there's our negatives from our batteries. What's going on here?
Off you go. Go. Go, go, go. Go. Come on. Bengals. Go. Go. Come on.
And these are the negatives for the batteries. Start in a minute. All right, so now we're down to this wire, which was going to our primary and where our distribution panel was. He's chugging. So this is our primary distribution. And because I've got a dual 175 amp, so it's pretty much a 200 amp service. We've pretty big wires. These are going to be the biggest ones in the system, which definitely makes them the hardest to deal with. So you can see here, we're talking AC out, hot leg, AC out, hot leg 2. So it's same setup as we had coming from the generator and the generator coming in. I also have the generator going 240. The advantage to having 240 is like your dry, for most households, is going to be like your dryer and things like that are going to run on a 240 leg. Like for me, it's my lab and equipment like that. And so what's happening with 240 is that rather than just having one bump, because power goes like this in like valleys and peaks, and it's the differential between the two things is where we draw our power from. And so however many times that happens is what we call today hertz, how many times in repetition that happens. And you'll notice most of your equipment will say 50 to 60 hertz on it. Well, some of your more powerful equipment need more than that, and that lag time is enough to slow them down and depower that machine. So they put it in on 2-phase. Yeah, see, these are the worst to work with. They put them, you run 2 phases, and now you got a substantial amount more power available. We'll dig that out later when we're not on video, so everybody don't have to watch me dig that out. So now we're down to things coming and going from our solar controller. So, and our communications bank. So this is going to be our first thing, and this is just a thermostat, nothing real special about it. And that's going to plug into here, and you can see it just says battery temp. And that's just going to, all that's doing is checking your battery temperature. Awful important piece, but not real complicated. And because obviously when it's too hot or too cold, your system doesn't really want to work right. Put that in the bucket with the electrical parts, please. Okay, now this one here is a communicator from the inverter. So, and this actually I don't ever use. This is a remote, and I can actually adjust a lot of things and monitor things from my phone. I don't ever do that. And here, I'm going to leave that one plugged in back there actually, because that one's horrible to get to. So I'm going to unplug that one from here. This is talking to your actual inverter and giving it a talking to, seeing what's going on. I'm just going to roll that up in here for now. And so now we're down to the one inside, which goes to the solar controller in and of itself. And so here we can see we've got our controller, and that's creating our communications right there. I'm gonna pop that one out, get that out of the system. Now all we're down to is our solar wires. So you can see PV plus, PV negative, battery plus, battery negative. Same skinny over here. And this here is the brain box for the whole system. So the one of these communication cords is going to the back of this brain box. And we'll take that off in a minute. So we come over here, and this is the battery negative, and we can see this one was already pre-wired into this. So I just took and wire nutted that, and that wire actually came wired into the system. So, and this is from both of our solar controllers. So there goes our battery negatives. And your battery positive, they are not a shared wire. So we actually have 2 wires going to the battery positive, and that's going to go to your PV array right here. So these are going to go to your 2 breakers right there. Battery positive. Okay. So these are our battery positives. These are going down to these 2 bad boys. And now here's the PV positive that's going up to this photovoltaic array ground fault detector. And that gives it a little bit of safety. And here's the other PV plus. And you can see these wires. It's this is Outback system, and I chose them mostly because this is really one of the only off-grid. Most of your systems aren't really made for off-grid, like your Tesla battery. Your Tesla battery is made to be charged up overnight, or charged up during the day, and then overnight you run off the Tesla battery. So it's really just kind of meant to just be charged and uncharged every day. It's not the same as living off of solar.